Ready? Question 1. I'll give you a few moments. What is X? How would you respond? Assessment in mathematics has a direct impact on students' teaching and learning experience. How? Is it a positive or negative impact? Which assessments should we choose to have the most positive impact on the students' teaching and learning experience? Well, we typically use 3 types of assessments. Diagnostic, to determine the nature of learning for feedback and intervention. Formative, to determine the direction of teaching and learning. Summative, to assess achievement for reporting and decision making. Under each of these types we have a number of strategies, including observation, questioning, interviewing, performance tasks, self and peer assessment, work samples, portfolios, and classroom and standardised tests. Whilst we could easily classify these strategies as either diagnostic, formative or summative, the key thing to remember is it is our purpose and what we do with the results of these assessments that is important. I've selected to discuss the questioning and self and peer assessment strategies because they align with constructivist and humanist learning theory and pedagogy. They build on the idea that learning is a social experience, most effective when it is authentic, connecting with the interests and lives of the learner, and enables them to realise their potential. They also align with my beliefs that teaching is a fluid process in which the teacher and students engage in a process of mutual discussion and shared learning, exploring their attitudes and beliefs about mathematics. Within these strategies, there is also the opportunity to act on my own strengths and values to help students deepen their understanding, explore their own creativity, accept responsibility for their learning, and appreciate the role of mathematics in their lives. These strategies have also been shown by Hattie as having the most significant impact on student learning. Let's explore these strategies using ACMNA 125, a Year 6 number and algebra strand exploring fractions. Let's say we had a number line on the board and some common fractions. We could open the lesson with a question. For example, how can we figure out where each fraction would be placed on this number line? This would allow us to determine students' current knowledge and understanding of fractions. Students would then be invited to share their solution with the class and receive feedback on their response. We could then build on this knowledge by asking a subsequent question. For example, what other strategies could we use to solve this problem? Students could then use the think, pair, share strategy, giving them feedback on their solutions and exploring those that worked and those that didn't. This would demonstrate to students the importance of problem solving, understanding, reasoning, and fluency. However, if we ask closed questions, for example, where is 2/3 placed on this number line, and we chose the first student without giving others adequate time to think, and we only give positive feedback on the correct answer, what we are demonstrating is important is speed, accuracy, and recall. Okay, once the think, pair, share strategy is completed, we can place some less common fractions with common denominators on the board, allowing the lesson to progress, and then use self and peer assessment strategies to conclude. Students would reflect on the processes they used to solve the problem with the less common fractions, self-assess their learning and achievement, and then conduct the same assessment with their peer. Each student would then reflect on the differences between the 2 assessments of their work. The benefit is that students are often the best assessors of their own thoughts and feelings about their learning and achievement. With this strategy, they are actively engaging with their own work and each other to share their cognitive processes. The self-reflection on their thinking allows them to develop metacognitive strategies. However, getting to this point takes time and considerable planning, and students may not be familiar with giving and receiving constructive feedback. The use of both strategies requires preparation and planning to be effective. They also depend on a classroom environment that is supportive and collaborative, one in which the teacher models effective feedback processes, engages in dialogue, and openly reflects on their own practice in the classroom. The background of students is also a factor, as they may not be familiar with open-ended questioning or feedback processes separate from the teacher. Both strategies create a socio-constructive dialogue, extending students' mathematical vocabulary, moving their learning from the concrete to the abstract. It also enhances their ability to self-reflect and develop as independent learners, deepening their critical thinking skills as they attend to other students' responses and realise maths is more than right or wrong. There are multiple solutions to a problem. This realisation empowers students to see that they can engage with mathematics, they can develop unique solutions to problems, and by sharing their solutions they can teach their peers and sometimes their teachers. With record keeping and reporting, it is important that we connect it to the curriculum. That is, what we are assessing, recording and reporting connects to what and how we are teaching. We should use a range of evidence to enable us to record and report students' achievement to stakeholders, including students, parents, school and government, in accordance to the mathematics curriculum content and proficiencies. It is also important that the information we record and those we report to can understand the students' unique circumstances. For for example, their linguistic, cultural, religious, and SES background, and any physical, social, or intellectual disabilities, as these can have an impact on their mathematics learning and achievement. So back to the statement. Let's see if we can build on it with what we have discussed. Questioning in self or peer assessment strategies have a positive direct impact on the student's teaching and learning experience by deepening their knowledge and understanding through a socio-constructive dialogue and encouraging them to be independent learners by reflecting on and assessing their own learning and achievement in mathematics. It is important we support these and other strategies with inclusive assessment, record keeping and reporting principles that enable us to record and report student achievement against the mathematics curriculum content and proficiencies to all stakeholders. Okay, so let's get back to the question. I'll give you a few moments to read it again. So how would you respond now?